The great filter, where is everybody? The question is simple enough to ask on a clear night, standing in your garden, looking up at the scatter of light above you. It has haunted physicists and philosophers for decades, and it goes like this: if the universe is so vast, so old, and so full of possibility, where is everybody? It was Enrico Fermi who first voiced it, not in some grand lecture hall, but over lunch at Los Alamos in 1950. The Manhattan Project had just ended, the world was changing, and Fermi, between mouthfuls of food, turned to his colleagues and asked, "Where are all the aliens?" Not as a joke, as a genuine puzzle. Because the numbers do not lie. Our galaxy alone contains somewhere between 100 and 400 billion stars. Many of them have planets. The Kepler telescope showed us that planetary systems are not rare at all. They are common, perhaps even the rule rather than the exception, and this is just our galaxy. There are 2 trillion galaxies in the observable universe. 2 trillion, each with hundreds of billions of stars, each star a sun, many surrounded by worlds. The mathematics is almost brutal in its simplicity. Even if intelligent life were extraordinarily rare, even if only 1 in a billion planets developed civilization, there should still be millions of advanced societies out there right now, scattered across the cosmos. Some of them would have arisen billions of years before us. Billions of years is an almost incomprehensible amount of time. Civilizations that old could have colonized entire galaxies. We know this because we understand how fast information travels. Light moves at 300,000 kilometers per second. A fleet of self-replicating probes, traveling at just a fraction of light speed, could spread across the Milky Way in a few million years. A few million years is a blink compared to the age of the universe. 13.5 billion years old. If even one civilization had taken that step, if even one species had decided to expand into the stars, the galaxy should be full of them by now. Their signals should fill our radio telescopes, their megastructures should glow in infrared surveys. Their probes might already be here, drifting through our outer solar system like silent seeds. But we see nothing, we hear nothing. The sky is quiet. This silence is what astronomers call the Fermi Paradox, and it has no single agreed answer. Instead, there are many hypotheses, ranging from the comforting to the deeply unsettling. Perhaps intelligent life simply does not arise very often. Perhaps Earth is a miracle, a 1 in a trillion accident of chemistry and timing. The conditions that allowed life here might be far rarer than we assumed. The right star, the right distance, a large moon to stabilize the axis, Jupiter to deflect asteroids, plate tectonics, magnetic fields, liquid water. All of these things had to align, perhaps over billions of years, for even a single cell to form, but this explanation has trouble with recent discoveries. We now know that extremophile organisms thrive in conditions we once thought impossible. Life exists in boiling acid vents on the ocean floor, in Antarctic ice, in radioactive waste. The universe seems remarkably good at finding ways to sustain biology wherever it can. And organic molecules, the building blocks of life as we know it, have been detected in interstellar clouds, on comets, and in meteorites that fell to Earth. Chemistry does not seem to be the bottleneck, so perhaps life is common, but intelligence is rare. Perhaps there is something extraordinarily difficult about evolving a species capable of building radio telescopes and sending probes into space. After all, dinosaurs ruled this planet for 160 million years without inventing algebra. Most species never developed technology at all. But again, the sheer scale of the universe makes even this explanation feel thin. If intelligence arises on just 1 planet in every billion, that still leaves millions of civilizations across the observable cosmos, and many of them would be far older than us with vastly more time to develop and expand. Which brings us to a darker possibility, one that gives the Fermi Paradox its most famous name, the Great Filter. The concept was formalized by astrophysicist Robin Hanson in 1996, but the intuition is older. The idea is this: somewhere along the path from simple chemistry to galaxy-spanning civilization, there exists a barrier, a filter, that is extraordinarily difficult to cross. Most species hit it and do not survive. The critical question is where this filter lies. Is it behind us or is it ahead? If the Great Filter is behind us, then we are among the very few species that have already passed through it. Perhaps the origin of life itself is the filter, an event so improbable that it has happened only a handful of times across the entire universe. In this scenario, we would be profoundly alone, but also profoundly fortunate. Every time we search for extraterrestrial life and find nothing, it would confirm that we are something truly rare. But if the great filter lies ahead of us, then the silence of the cosmos takes on a very different meaning. It would mean that civilizations do arise regularly across the universe. They develop technology, they build radio telescopes, perhaps they even achieve interstellar travel, and then at some point something happens, something that prevents them from ever becoming the galaxy-spanning species we might expect. And we would have to ask ourselves, what is that something? The most uncomfortable answer is that civilizations tend to destroy themselves, not through invasion or disease or natural disaster, but through their own technological progress. Nuclear war, engineered pandemics, runaway artificial intelligence, environmental collapse, resource exhaustion. There are many ways a species could reach a point where its tools become too powerful for its wisdom to manage them. This is not science fiction speculation. We can see the trajectory in our own history. In just 200 years, humanity has gone from horse-drawn carriages to splitting the atom, from oral tradition to artificial intelligence that can write poetry and diagnose diseases. The pace of technological change is accelerating exponentially, and yet our political systems, our social structures, our capacity for long-term thinking, these have evolved far more slowly. We are a species with godlike technology and medieval institutions. That gap between what we can do and how wisely we do it is widening every year. But perhaps the great filter is not self-destruction at all. Perhaps it is something more subtle. A civilization might simply plateau, reach a level of technological sophistication where further expansion becomes unnecessary or undesirable. Why cross the stars when virtual realities offer infinite worlds? Why colonize hostile planets when Earth-like conditions can be engineered in orbit? Or perhaps advanced civilizations deliberately hide. This is known as the dark forest hypothesis, proposed by Chinese science fiction writer Liu Cixin. The idea is that every civilization knows other civilizations exist, and every civilization understands that any contact could be dangerous, because you cannot know whether another species means you harm. So the rational strategy for every civilization is to remain silent, to hide, to listen without broadcasting. In this scenario, the universe is not empty. It is full of civilizations, all holding their breath, all afraid to reveal themselves. And any signal we send into space might be like striking a match in a dark forest, illuminating us to every predator within range. It is a chilling idea, but it also raises its own questions. Why would every single civilization choose silence? Surely some species would be more optimistic, more curious, more willing to take the risk of contact, unless those who did broadcast were eliminated by those who remained quiet, which returns us once again to the possibility that the universe is not peaceful. There are other explanations too. Perhaps we simply have not been listening long enough. Human civilization has only been broadcasting radio signals for about a century. In cosmic terms, that is less than a heartbeat. The galaxy is 100,000 light-years across. Our signals have reached barely a fraction of a percent of nearby stars. We are like someone who has just lit a candle in the center of an enormous cathedral and declared that no one else is there because they cannot yet see another flame. Perhaps we are listening on the wrong frequencies. Perhaps advanced civilizations communicate using methods we have not yet discovered. Neutrino beams, gravitational waves, quantum entanglement protocols we do not yet understand. Our radio telescopes might be like Stone Age ears trying to hear a conversation conducted in ultraviolet light. Or perhaps the answer is far simpler than any of these dark scenarios. Perhaps intelligent life does exist out there in abundance. Perhaps civilizations rise and fall across the cosmos in cycles that rarely overlap. The universe is so vast and so old that two species might simply never be awake at the same time in the same region of space, like fireflies flashing in a meadow, each one bright for a moment, then gone, never seeing its neighbor because their brief windows of activity never coincide. This last explanation is perhaps the most comforting. It suggests that we are not alone, that civilizations do exist across the stars. They just cannot find each other because the universe is too big and time is too long. In this view, the Fermi Paradox is not a paradox at all. It is simply a consequence of scale. But whichever answer turns out to be correct, one thing seems clear. We are living through an extraordinary moment in cosmic history. We are one of the first species on this planet capable of asking these questions seriously, of building instruments that can detect planets around distant stars, of sending probes beyond our solar system, of imagining what might lie beyond the darkness between the stars. Whether we are alone or not, Whether the great filter lies behind us or ahead, the responsibility is ours to decide how this story continues. We have crossed thresholds in just a few generations that previous species never imagined. We can now edit genes, build machines that think, and peer back to within 100 million years of the Big Bang itself. The question Fermi asked over lunch 75 years ago remains unanswered, but we are the first generation in human history with the tools to begin finding out. Perhaps our probes will detect signals from another world. Perhaps future telescopes will find biosignatures in distant atmospheres. Perhaps one day, centuries or millennia from now, humanity will look up at the stars and finally see that we are not alone after all. Or perhaps we will discover something far more profound, that we truly are rare. That life, conscious and wondering, is one of the most precious things in the universe, a fleeting spark of awareness in an ocean of darkness and silence. And if that turns out to be true, then every moment of curiosity, every act of kindness, every song sung under the night sky becomes infinitely more valuable than we can possibly imagine.